Hello and welcome to our ISyE 315 final presentation. We are Group 13 and we are Michael Sukar, Moath Sharaya, Leonard Taft, Joseph Hillstrom, and Claire Johnson. For starters, as a brief executive summary, we have decided to continue our welding outsourcing. Our decision was economically justified, as you will see in later slides. In addition, we have decided to take an environmentally friendly approach and create a better working environment for employees at Tomahawk Inc. Here are some of the key features this presentation will include. The layout of the machine shop will include 101 machines, which will be placed 3 feet apart and have 9-foot aisles to accommodate for heavy machinery and equipment. We have also decided to create an administrative department. This department will group all business and management offices. In addition, we used a series of complex charts and tables in order to determine the overall flow layout of the facility. Furthermore, we have decided to use insulated doors and proper ventilation units in paint rooms for health and safety reasons. We will also be applying sustainability initiatives such as using electric forklifts, implementing LEED standards, and having a garden roof. Finally, we have decided to use a complex security system comprised of cameras and badge access to improve productivity and reduce thefts. In order to come up with the machine shop and overall layout, the following crucial steps were followed in the specified order per trade. If you are wondering why the sustainability analysis is not part of the flowchart, it is because a great deal of attention was given to it at multiple points throughout the project. So, we thought that it wouldn't be right to pinpoint it to a specific section on the chart.
For the capacity analysis of this project, we made 3 analyses using the different growth percentages provided. We assumed that the threshold of utilization to be 90%. So if the utilization of any year is greater than 90%, we need to add additional machines to meet the demand. For the normal growth of 10%, the analysis is shown in these 2 tables. The yellow cells indicate the years when we needed to add additional machines. Based on the capacity analysis of the previous tables, we made this table that shows the machine requirements. We can see on the left the types of machines and on the right the number of machines required. The payback analysis was made based on the capacity analysis. We can see here in this table the payback analysis for the 10% growth. At the left, we have the expected demand in units for the first 11 years of operation. The columns in the middle shows the costs of purchasing the different types of machines. The net cash flow column is calculated by subtracting the total cost of purchased machines from the revenue of each year. The revenue is basically the number of units demanded multiplied by the difference in the unit costs of producing inside and outside the company. The difference is $2.5 per unit. Using the IRR function of Excel on the values of the net cash flow column, we find that the rate of return is 9.69%. Since this rate of return is less than the MARR, we should not bring welding on site.
We use relationship charts and diagrams to plan the layout for the machine shop as well as for the overall layout. Both flow and non-flow factors were considered. We first created a relationship chart for non-flow considerations. Then, using the to and from flow values from the past year of production, we created another relationship chart. Then, using the table on the left, we combined the scores and gave each relationship an updated ranking, which you can see in the chart on the right. Here you can see the final relationship chart, with a key explaining the meaning of each letter. A is absolutely necessary, E is especially important, I is important, O is ordinary closeness, U is unimportant, and X is undesirable. This is the best relationship diagram for the machine shop. As you can see, the color of the lines correspond to how close the machines should be to each other.
Taking these considerations from the relationship diagrams, we created block diagrams for the machine shop and were given total square footage of 60,000 square feet. For the first diagram on the right-hand side, we made a 400 by 150 foot space to fit in the overall L-shaped facility. We used the number of machines determined earlier in the report and their square footage and included them in a key on the right of the block diagrams. This option includes shipping and receiving next to assembly, punch press and brake press near each other, and has shipping assembly area against the walls to save space for wider aisles later. The block diagram on the left of your screen shows the flow of the production line and is a 300 by 200 foot space. Each workstation is placed near the one that will be executed right before it, and the flow of each individual machine has a nice layout for the workers in this facility. A part of this diagram is that there is a large amount of space between each section of machines. However, there is less room in the middle for easy transportation, but each job is separated and will operate without interference. For the overall block diagram, we were provided that the total square footage is 110,000, and we were given this outline of the L shape you see on your screen. For block diagram 1 on the left-hand side, we failed to achieve that shipping and receiving is in the machine shop and could be potentially far away from inventory and tool storage. However, restrooms are centrally located, the manager's office is close to the machine shop, and there's a nice flow overall with many spaces along the wall and long hallways of flow between spaces. However, the production manager's office and quality laboratory are a little crowded, leaving smaller hallways in this area. Block diagram 2 on the right, the main thing that was changed is that the block diagram dimensions are at the top half of the L floor plan. We placed shipping and receiving near the bottom of the machine shop, close to both the tool and inventory storage. We kept the restrooms close to the lunchroom, the conference rooms near each other, and both too close to the administrative and president's office. Since these areas are pushed against the wall, the space allows for easy flow throughout the facility.
To determine which alternative layouts to use for the machine shop and the overall layout, we utilized factor analysis. Factor analysis gives factors such as safety a relative importance and numerically determines each alternative's satisfaction of the factors. Our team chose the top 3 factors to be material handling, safety, and flow. For the machine shop and overall layout, we established a different relative importance for each factor as seen in the prioritization matrices in the next slides to properly assess the alternatives. In the machine shop, we selected layout 1 as its design favored a much higher safety rating and totaled more points. As for the overall layout, the placement of the machine shop in layout 2 proved to greatly benefit the material handling, which made it the clear favorite. In both cases, our team is confident that the factor analysis revealed the superior designs.
For material handling systems, first we will use trucks to transport our heavy products, including the operator down turret truck and sit-down counterbalance truck. We have created large enough aisles to account for these large machines. For positioning equipment, we'll use the air film device to move heavy loads at a cheap cost. Another piece of equipment we will use is a dock leveler. For the unit load formation equipment, we will use crates and pallets to move these crates onto the trucks and air film devices. We will use a cantilever rack for storage equipment, and since table and chairs take up a lot of space, we will also use a mezzanine. For identification and control equipment, we will do this manually since identification and associated communication can be performed without any specialized equipment. 2 sustainable initiatives have been implemented to preserve the environment and increase our savings. The first is to switch to electric forklifts that have 0 emissions. The price of these is between $20,000 and $45,000, in addition to $2,500 to $5,000 battery and charging system. The second initiative is to switch to LEED standards when designing the light fixtures, and like the first one, this will lead to higher employee satisfaction, and although it has a steep starting investment, the company will save money in the long run when they cut down on gas price. During this analysis, we assumed that Tomahawk Metals would have an unlimited budget to allocate machinery and equipment, and our analysis was done accordingly. However, the facility should invest in security measures like security guards, restricted key access camera systems, and alarms. This security will result in a decline of stolen stock and minimize losses for Tomahawk. We used factor analysis, considered space utilization, flexibility, material handling, employee crossover, contact points, and ease of supervision in our layouts, and weighed the pros cons from the diagrams to select machine diagram 1 and overall layout block diagram 2. We took these diagrams and added on features on the screen that you can see, like exits, ramps, and safety supplies, so you'll truly be able to see what our diagrams will look like in the facility place. That concludes our presentation. Thank you for taking the time to meet with us today, and we hope to be in contact in the future to discuss implementation.